Okay, hi everyone. So see you guys again. In today's class, I'm going to talk about the movement of substances across the plasma membrane. And in this class, I want to focus on the specific part known as simple diffusion process. Simple diffusion process is a simple process, but still you need to be careful with the loss of these details inside. Okay, so that you won't miss few points while answering the SPM questions. Okay, so as you know, there are two types of transport across the plasma membrane. You have passive transport and active transport. The word passive indicates that this transport do not need energy. Okay, see this picture I show you here. Alright, so passive transport is like, imagine yourself going down here. So no energy is needed. You move from high place to low place. So same concept. Passive transport, the substance will move from high concentration to low concentration. And the second type of transport is active transport. In active transport, you will need the use of energy, okay, in the form of ATP. Okay, so again, in this picture here, imagine yourself climbing up a hill. Of course, you will need energy. Okay, so you are going to move from low place to high place. So same concept again, in active transport, the substance, the molecules will move from low concentration to high concentration against the concentration gradient. Okay, so energy is needed in this case. Alright, now so let's focus on today's topic, which is the simple diffusion process. Okay, now so let's focus on today's topic, which is the simple diffusion process. Simple diffusion process can be defined as the movement of molecules or ions from high concentration region to low concentration region down the concentration gradient. What's the meaning of down the concentration gradient? Look at this picture. Okay, so in this picture you will see region A has higher or more concentration of molecules compared to region B. Now we will have a difference in concentration between region A and region B. So this difference in concentration between both regions is known as the gradient. The higher the difference, the steeper the gradient will be. So molecules from region A will go down the gradient to region B until they reach the equilibrium, okay, where the concentration will be the same. And this is the meaning of down the concentration gradient. So what substances can undergo the process of simple diffusion? Okay, number one, water molecules. Number two, carbon dioxide. And the third one is small uncharged particles. There are three factors that can affect the rate of diffusion. So before we talk about these factors, let's recap on what is the meaning of rate of diffusion. Rate of diffusion can be defined as how fast the diffusion process occurs. So the faster the diffusion process occurs, the higher the rate of diffusion. Okay, so now let's take a look at the factors. Number one is the concentration gradient. Number two, the temperature, and the third one is the TSA over V, which is the total surface area over volume. Alright, concentration gradient. The higher the concentration difference, the steeper the gradient will be, the higher the rate of diffusion. Remember the diagram I showed you earlier? Okay, so now imagine in region A, you have higher concentration of molecules. This will make the gradient to be steeper, and the molecules from region A will fall to region B faster. So the faster the molecule move, the diffusion process to occur faster, okay, and thus we say that the rate of diffusion is higher. Okay, second factor is temperature. The higher the temperature, the higher the rate of diffusion. How? okay, the heat energy supplied will be converted into kinetic energy. This kinetic energy will make the molecules to move faster. So the faster the molecules move, the faster the diffusion process will occur, making the rate of diffusion to be higher. Okay, and then the third one is the TSA over V, total surface area over volume. The higher the ratio, the total surface area over volume ratio, the higher the rate of diffusion. In other words, the smaller the substance, the faster the diffusion process will occur. Okay, so just imagine when you want to make a drink. Okay, so you have a cube of sugar and the normal sugar powder. So when you drop these two substances into a cup, powder will dissolve faster compared to the cube. So this explains the TSA over V ratio. So the higher the total surface area over volume ratio, the higher the rate of diffusion. Okay, so your body will maintain the TSA over V ratio to be high at all times. For example, alveoli in your lungs, okay, and for plants that have root hair. So your alveoli in your lung, the TSA over V ratio must kept high. Why? So that the rate of diffusion of the gases, which is your oxygen and carbon dioxide, the rate can be maintained at high level. We want to have a very fast diffusion process of oxygen entering our body and very fast diffusion process of carbon dioxide leaving our lungs. Okay, one extra point here is the distance. Distance will decrease the rate of diffusion. The longer the distance, the lower the rate of diffusion. Okay, so that's all for today. Thanks for watching. Thank you.